All right, I'm going to describe how we can make maps of exoplanets using planetary dynamics. So first I'll start by describing how we make maps of planets like Earth when we live on them. So in the old days, we would send brave explorers and they would sail along the coast and somehow keep track of their location using the stars. And then when they came home, they could actually recreate a rough map of the coastline that they'd been traveling along. With modern technology, we do much better than that. We just send satellites in orbit around Earth. They take lots of images, lots of photos of Earth, and we stitch those together and we make a very accurate map of how our planet looks. Now, of course, it's prohibitively expensive to send either astronauts or even satellites to an exoplanet because the nearest exoplanets are 10 or 50 light years away from us. So how can we do better, or at least cheaper? Well, one option is just to take a picture of one of these exoplanets with a really, really big telescope. So you can do the math and figure out how big a telescope would have to be if you wanted to spatially resolve the planet, like we do, say, with the Hubble Space Telescope when we're looking at Mars or Jupiter. It turns out you need a very big telescope. You need a telescope about the size of Earth. Or if you want to do it on the cheap, you can launch a bunch of very big 10-meter telescopes and have them fly in a formation pattern about the size of Earth. Either way, that's a tall task. And so for the foreseeable future, we will not actually be able to spatially resolve extrasolar planets. Instead, we're going to see exoplanets as what Carl Sagan called the pale blue dot. So all of the light will be coming from just basically a single pixel. Right? So the question is, how can we map a planet if it just appears to us as a pale blue dot? And the answer is planetary dynamics. So basically, a real planet doesn't just sit still, boringly like this in space. In fact, a real planet does something like this. It rotates. And as it rotates, different features, continents and deserts, forests, oceans, clouds, are rotating in and out of view. It turns out that those changing colors of the pale blue dot can be inverted, and you can actually create a map of where features lie along the equator. So it's basically a one-dimensional map along the equator, telling you where the oceans are and where the continents are along the equator. To make a two-dimensional map of the pale blue dot, you have to use another trick, which is if the planet's rotation axis in general will be a little bit tilted with respect to its orbital axis. And so if I'm the star, as the planet goes around, as it goes around its star like this, different parts of the planet are being illuminated differently as a function of time. Okay? And that's what causes the seasons on Earth, for example. It turns out that also that changing illumination also allows us to create a two-dimensional map of the pale blue dot. And so just using the changing colors because of rotation and because of the orbit of the planet, we can actually create a two-dimensional map of the pale blue dot.